So we have got the value of omega of P1, P2, etc. Pt. Now let us find the value of omega of t. Omega of t എന്ന് പറയുന്നത് that will be summation over all the t combination. ഇനി total there are r objects. അപ്പം we are taking the r permutations. So the number of t combinations out of r objects will be rc2. അപ്പം ഈ ഒമേഗ pi1, pi2, pit എന്ന് പറയുമ്പോൾ നമുക്ക് rct terms ഉണ്ടാവും. Now for each of them, each of this omega pi1, pi2, pit will be this value. അത് നമ്മൾ ഏത് t properties എടുത്താലും number of permutations ഇങ്ങനെ ആയിരിക്കും വരിക. So omega of t will be rct times n minus t factorial by n minus r factorial. So that is the value of omega of t. And now let us find the value of d of nrk. So by generalized principle of inclusion and exclusion, so d of nrk will be equal to e of k. Now e of k will be summation over I equal to 0 to r minus k minus 1 raised to I k plus I ck omega of k plus I varum. That will be the value of e of k. Now let us substitute the value of omega into it. So that is minus 1 raised to I k plus I ci. So omega of k plus I will be ct upon r c k plus I into n minus t upon n minus k minus I factorial by r minus so we will have n minus t by n minus r factorial upon n minus okay, that will be n minus r factorial itself. Now this is equal to 1 by n minus r factorial summation I equal to 0 to r minus k minus 1 whole power I rc k plus I into k plus I ck into n minus k minus I factorial. Now we have this result. So nck into kcr, so that will be equal to ncr into n minus r k minus r. Okay, so using this, അല്ലെങ്കിൽ ഇത് simplify ചെയ്താൽ മതി. ഇത് simplify ചെയ്ത് കഴിയുമ്പോൾ we can put it in this form. So 1 by n minus r factorial into summation I equal to 0 to r minus k minus 1 raised to I. So nck into kcr. So here k in place of k you will have k plus I. So we are going to get rck into n minus r. R minus k c k minus r. So that is k plus I minus k. So we'll get rck I n minus k minus I factorial. Again the summation is upon I. So here rck is independent of I. That also will come out of the factorial. So that will give you rck by n minus r factorial summation I equal to 0 to r minus k minus 1 raised to I r minus k ci into n minus k minus I factorial. So therefore d of nrk will be given by this expression. So by generalized principle of inclusion and exclusion, so this will be the value of d of nrk. And now let us look at the value of dn. So dn is obtained by d of nn 0. The number of fixed points will be 0 in that case. So k is 0 out. You will get NC 0 by, so here you will have n minus n factorial summation I equal to 0 to R, okay, 0 to n varum, minus 1 raised to I. So this will be NCI into n minus I factorial. Now NC0 is 1, 0 factorial is 1, so that is summation I equal to 0 to n minus 1 power I. So you will get n factorial by I factorial. So here n minus I factorial cancel out. So that is equal to n factorial into summation I equal to 0 to n minus 1 power I 1 by I factorial. So that is the expression for dn. So therefore dn is equal to n factorial into summation I equal to 0 to n minus 1 power I by I factorial. So from this we will also get few corollaries. So you take dn, so dn is n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus etc. plus minus 1 whole raised to n into 1 by n factorial. So if you take limit n tends to infinity dn by n factorial, so that is limit n tends to infinity summation I equal to 0 to n minus 1 whole power I by I factorial. So you know this is the series for e raised to minus 1, so that is approximately equal to, so the limiting value is e raised to minus 1, so which is equal to 0.367. So that is the limiting value of dn by n factorial. And these are few recurrence relation involving dn. So if you take dn will be equal to n minus 1 into dn minus 1 plus dn minus 2, and again dn is equal to n dn minus 1 plus minus 1 whole raised to n. So these are, so this is how you find the number of derangements using the generalized principle of inclusion and exclusion.